Hello and welcome to another episode of the Pharmaceutical Calculations Solve Along. In this session, we are going to review isotonicity calculations, and we are going to focus essentially on the sodium chloride equivalent method. Now, if you are watching this video live, then just be sure to leave your questions in the chats. I'll try and answer them as soon as I see them. Or if you are watching the replay, then be sure to leave your questions in the comments and I'll get to them also as soon as I see them. The way this session is structured is I try to organize the questions you're likely to see on an exam and try to put some part into it. So hopefully that should help you in how you do study. And if you like how the video is structured, just be sure to give it a like so that others could also benefit from the video as well. Now, having said all that, let's get right to the first question. Now, this type of question actually has to do with a situation where you have one drug and the weight of the drug is actually given in grams. And the first example we want to look at is this question right here. So what we have is the question saying, find the quantity of sodium chloride required in compounding the following prescription. The sodium chloride equivalent of cocaine hydrochloride is 0.16. And then it gives the prescription with cocaine hydrochloride being 0.2, sufficient quantity of sodium chloride, purified water to make 30 milliliters, and then you make isotonic, and then the directions is to put 1 drop in each eye. Now, one of the ways you know you want to use sodium chloride equivalent method is when it states in the question, find the quantity of sodium chloride. So phrases like find the quantity of sodium chloride tend to prompt and guide us to know that we need to use this type of approach. So the way you want to solve this type of questions typically is follow a series of steps. And I'm going to go through the series of steps that you want to use. And if you follow those with understanding, you should always get the question right. The first step, which we will put down as step 1, is to first of all determine how much sodium chloride itself will be needed if there was nothing else in the solution or the volume of solution to make it isotonic. So what that would mean then is we would take the notion that normal saline, which is 0.9%, is isotonic. And so that would imply that you have 0.9 grams of sodium chloride in every 100 milliliters of solution. We want to determine how many grams of sodium chloride will make the volume of the preparation, which in this case is 30 milliliters isotonic. So that's the first step. And once we identify that, we will go ahead and subtract the contribution of the components in there, and then that will give us the difference. So we can go ahead and solve for x here. X is going to be equal to 0.9 grams times 30 milliliters divided by 100 milliliters. Milliliters cancel out, and this essentially gives 0.27 grams. So what that means then is if you had nothing else in there but sodium chloride, you would need 0.27 grams or 270 milligrams of sodium chloride to make this volume isotonic. But notice that you do have some cocaine hydrochloride in there, right? So we want to find out how much sodium chloride will be equivalent to that amount of cocaine hydrochloride to provide the same osmotic pressure. And that is where you want to use the E value, right? So the E value is more or less like your exchange rate, which allows you to convert the osmotic pressure or the amount of drug of a given drug that has a specific osmotic pressure to the amount of sodium chloride that will give the same osmotic pressure. That's what the E value does. And so in step 2, let's do that right here. So in step 2, what we actually want to do is find out what the equivalent amount of this cocaine hydrochloride is. And so the way you do that is you take the weight of the ingredient in grams. Okay, you always have to be in grams. Otherwise, you'll be off. So you take the 0.2, because here is 0.2 grams. You multiply that by the E value, which is 0.16. So times 0.16. That gives a value of 0.032 grams, and this is also NaCl. So just for clarity, you have sodium chloride in both instances. All right, so I'm just going to repeat myself for emphasis. This 0.27 grams is the amount of sodium chloride that is needed to make 30 milliliters isotonic. Then in step 2, what we are determining is the equivalent amount of sodium chloride, which will give the same osmotic pressure as 0.2 grams of cocaine hydrochloride. Okay, and once again, your E value here is like your exchange rate. If you wanted to convert between like dollars and euros, you have an exchange rate. It's the same thing here. This E value here is more or less what allows you to convert the amount of any given substance to its equivalent in sodium chloride. So we just found those two. What do you do in step 3? Step 3 is you find the difference between step 1 and step 2. All right, so what that will look like then is in step 3, you're going to take the value you had in step 1, which is 0.27 grams, and you're going to subtract from it the step 2 value, which we calculated here to be 0.032. And so that's also in grams. And what you end up having is 0.238 grams. So what it means actually is that for you to adjust the tonicity of this preparation so that it becomes isotonic, you need to add 0.238 grams. Now, if all of this is not very clear for you, or you need a more thorough or more detailed explanation of isotonicity calculations, then I have a link in the playlist. You want to check that out so you can actually review the core concept or refresh your mind as to what is going on here. So there are 3 things you should know. There's a solution can be hypotonic, which has less solute. It can be isotonic, which is the same osmotic pressure as bodily fluids, or it can be hypertonic, which has too much osmotic pressure or too much solute in there. We always want to aim for something isotonic, especially when you are preparing ophthalmic preparations or injectables. All right, so the whole goal here is to introduce more solute into the solution so that you can elevate the osmotic pressure to get it to isotonicity. All right, so that's what we're doing here, and this is the first type of example you would see. It is the example where you have one drug and you have the weight given in grams. Okay, so let's look at another example and we can actually reinforce that concept. So in this question, it says, find the quantity of sodium chloride to be used in compounding the following prescription. The sodium chloride equivalent of epinephrine sulfate is 0.23. And then you have once again, you have the prescription. You have ephedrine sulfate, 0.5 grams. You have the sodium chloride as sufficient quantity. And then you're supposed to make a total preparation of 50 milliliters. And it gives you some directions as well. Okay. So we're going to repeat the steps that we did in the first example. Here again, you have one drug or one ingredient, which is ephedrine sulfate. The weight is in grams. That's important. And we want to follow the same steps to solve this type of problem. So in step 1, we want to determine the amount of just sodium chloride by itself that will make a 50 milliliter volume isotonic. So that's the first step, right? So what we'll do is we'll take the idea that 0.9 grams in 100 milliliters is isotonic. That's based on normal saline 0.9% solution being isotonic. Then we'll go ahead and solve for the quantity in grams that will make 50 milliliters isotonic. We can solve for X. X is going to be equal to 0.9 grams times 50 milliliters divided by 100 milliliters. That gives a quantity of 0.45 grams. So if you took 0.45 grams or 450 milligrams of sodium chloride and dumped it into a 50 milliliter volume of purified water, that preparation will be isotonic. But notice we have ephedrine sulfate in there, so we want to find the contribution from ephedrine sulfate. All right, so that will be our step 2. So in step 2, we will take the amount of ephedrine sulfate Please notice it has to be in grams, so we'll take 0.5 grams. Then we'll multiply that by the E value, which is 0.23, and that gives 0.115 grams. Now all of this at this point in time is in terms of sodium chloride. So we've done those two steps. In step 3, once again, you want to find the difference between step 1 and step 2. So we'll take the 0.45 grams and subtract from that the 0.115 grams. And what you end up with is 0.335 grams sodium chloride. Okay, so that's by how much you need to top up the amount of sodium chloride in there to ensure that you have an isotonic solution. Okay, so that's the first type of problem you are likely to see. Now, the second type of problem you're likely to see is one where you have one drug, but the quantity is given in terms of a ratio strength. All right, so one trick or one tip you want to keep in mind is for these type of computations, you want to be sure that you really understand the ways in which you express concentration. You want to understand ratio strength. You want to understand percentage concentration or percentage strength. Those are very important in helping you understand and solve these type of questions. Now, for this particular type, we'll go off with this example. Let's try this example. All right. So in this example, it's a little bit wordy, but it actually illustrates the point very clearly. It says a chemist was asked to compound 60 milliliters of an isotonic eye drop. Drug Y is a liquid with E value 0.33, and sodium chloride will be used to prepare a final concentration of 1:5,000 weight in volume. How many milligrams of sodium chloride must be added to make the eye drops isotonic? Answer must be numeric, nearest whole number. All right, so here we're going to go through the same steps, step 1, 2, and 3, because we are adjusting with sodium chloride. The main difference would be in step 2 when we begin to find the contribution of the drug. Okay, so let's start off with step 1. So in step 1, we're going to determine the amount of sodium chloride that will make a 60 milliliter volume isotonic. So we start off with 0.9 grams over 100 milliliters. You want to kind of remember this particular ratio. And then we set it equal to some quantity in grams over 60 milliliters, which is the volume. So we go ahead and solve for X, which is the unknown. X is going to be equal to 0.9 grams times 60 milliliters divided by 100 milliliters. The milliliters cancel out, and that's going to be equal to 0.54 grams. Now we move on to step 2. And in step 2, we want to find the contribution from drug Y. Okay? But notice it's given as a concentration is 1:5,000. So we want to first find what that amount is in grams and then multiply that value by the E value. So we will take 1 gram over 500 milliliters, and we are getting this ratio from the ratio strength. We multiply this by the volume of the preparation, which is 60 milliliters, so times 60 milliliters. This will give a value in grams, and then we'll multiply this value by the E value, which is 0.33, and this will give us the equivalent amount of sodium chloride, which will give the same osmotic pressure as the quantity of grams that was determined here. So if you go ahead and actually do that, the value that we end up with is 0.0396 grams. So we can move on to step 3. And in step 3, we'll find the difference between step 1 and step 2. So step 3, is going to be equal to difference between step 1 and step 2. So that will be 0.54 grams minus 0.0396 grams. And this is actually equal to 0.5004 grams. But notice the question says how many milligrams. So we do want to do a quick conversion. Using the conversion factor, 1 gram is 1,000 milligrams. The grams cancel out, end up with 500.4 milligrams. But the question says round to the nearest whole number actually. So that will be 500 milligrams. So the steps were very similar to the situation where you have one drug and the amount in grams. The main difference is what you do in step 2 by first ensuring that you have your quantity in grams. And you want to take the ratio strength, find the amount of grams that the drug actually contributes to the solution, and then you multiply that value by the e-value. All right, okay. So that distinction is important because sometimes it causes a lot of errors that I've seen on several exams. Let's move on to the next type that you're likely to see. So this is the example where you have two drugs and then the quantity is given in terms of a percentage strength. All right, so what would that look like? That's what we want to explore. So we'll use this example. And the question says, find the quantity of sodium chloride to be used in compounding the following prescription. The values of sodium chloride equivalent of epinephrine hydrochloride and scopalamine hydrobromide are 0.29 and 0.12 respectively. So the first thing I want to do is just pay attention to note that indeed we do have two components in there. You have the ephedrine and then the scopalamine. So what you typically do is you still go through the same steps, but in step 2, you actually do that step twice, essentially for each component, but you have to ensure that the actual amounts are in grams. So once we go through it, to be very clear how to proceed with that kind of situation. Now in step 1, we want to start off as usual to determine the amount of sodium chloride that is needed to make 60 ml isotonic. So we'll use 0.9 grams over 100 milliliters equals some quantity in grams over 60 milliliters. Now there's another way you can do that. You can simply divide 0.9 by 100 and just use that value, multiply that by the volume. All right, but this approach ensures that you don't make any omissions or careless errors. So we can go ahead and solve for x. X is going to be equal to 0.9 grams times 60 milliliters divided by 100 milliliters. The milliliters cancel out. And this is going to be equal to 0.54 grams. Now we can move on to step 2, which is where a lot of the fun begins. So we just go on to step 2. Now in step 2, we want to find the contribution from ephedrine hydrochloride and scopalamine. So we'll start off with the ephedrine hydrochloride, and that's a 1% concentration. So we would have 1 gram in 100 milliliters times the volume, which is 60 milliliters. This will give quantity in grams. Then we multiply all of this by its E value, which is given as 0.29. And that is going to be equal to 0.174 grams. We do a similar thing for scopalamine. hydrobromide, and that's a 0.5% solution. So we'll do 0.5 grams over 100 milliliters times the volume, which is 60 milliliters. Now the milliliters cancel out, and you multiply that by its E value, which is 0.12, and that's going to be equal to 0.036 grams. Now the next thing you want to do, just for clarity, is you need to add these two values, the 0.174 and the 0.036. So we'll do 0.174 grams plus 0.036 grams, and that's going to be equal to 0.21 grams. So once you've done this, you can now go ahead and do your step 3, which is going to be the difference between the 0.54 and then the 0.21. Okay, so step 3, that's going to be equal to 0.54 grams minus 0.21 grams. And so that will give you 0.33 grams. All right, so that's a typical example. You'll frequently encounter situations where you do have percentage concentration. You want to pay attention to what is going on in step 2. You first need to convert the percentage strength to the actual amount in grams. And so that's what this step is actually doing. It's actually converting that to grams, and then you multiply the amount in grams by its corresponding E value. All right, that's very important. What you do not want to do is multiply the 1 by the E value. That would set you down the wrong track. All right, so good stuff here. Once again, if you have any questions, just leave them in the chat, or if you're watching the replay, you can also leave your questions in the comments and I'll answer them as soon as I see them. Let's move on to the next type that you're likely to see. There are situations where you are actually going to have two drugs, one of which has a concentration as a percentage strength and the other as a ratio strength. And then also, instead of just using the actual solid sodium chloride, you are going to be using a solution to actually provide the sodium chloride that is needed. So that's what the term in parentheses is actually showing, and that's important to pay attention to. Okay, so what we want to do now is take a look at a question that will illustrate that. And here the question states, you have your entire prescription. You have Procaine hydrochloride, which is 1%. You have Benzalkonium chloride, which is 1:1,000. Then you have the volume, 50 milliliters. And the question is asking how many milliliters of normal saline should be used in compounding the prescription. And then the E value for Procaine hydrochloride is given as 0.2, and the E value of Benzalkonium chloride is given as 0.16. So here you want to actually follow the same series of steps. And just to make use of the real estate, we're going to start off with step 1 at the top here. So in step 1, the strategy is to find the amount of sodium chloride that will make 50 milliliters isotonic. So we will do 0.9 grams over 100 milliliters being equal to some quantity over 50 milliliters. Now, once again, the reason we are doing this is because 0.9% sodium chloride solution or normal saline is actually isotonic. All right. So with that ratio in mind, it means that we can scale down or enlarge the amount of sodium chloride that is needed for any volume. And that's the whole idea here. So we can go ahead and solve for X, which is the unknown. And X is going to be equal to 0.9 grams times 50 milliliters divided by 100 milliliters. The milliliters cancel out and you end up with 0.4 0.45 grams. Okay. Now, once you are done with that, you want to move on to step 2. And in step 2, we want to find the contribution from the Procaine hydrochloride and then the Benzalkonium hydrochloride. So let's start off with the Procaine hydrochloride. And since that is a percentage concentration, we are going to do 1 gram over 100 milliliters. So the reason we are doing that is 1% implies 1 gram of something out of 100. Okay, so that's where it's good to recall your percentage concentrations. Then we multiply this by the volume of the preparation. Here it's 50 milliliters. This gets us to grams, and it's the amount of grams that we want to actually multiply by the corresponding E value. Here the E value for Procaine hydrochloride is given as 0.21. And so that is going to be equal to 0.105 grams. We will repeat the process for benzalkonium chloride. So we'll do here benzalkonium chloride. And here we have a ratio strength. So we'll want to do 1 gram out of 1,000 milliliters because that's what 1 is to 1,000 really means. And then we multiply that by the volume, which is 50 milliliters. The milliliters cancel out. You're now in grams. And we multiply that quantity in grams by the corresponding E value, which is 0.16. And that turns out to be 0.008 grams. So what we need actually to do is to add the two values in step 2, which is 0.15 to the 0.008, and that will give us the total amount of sodium chloride there. So we'll do 0.105 grams plus 0.008 grams, and that's going to be equal to 0.113 grams. So once you're done with that, then you can speedily move on to step 3, which is going to be equal to 0.45 grams minus 0.113 grams, and that's going to be equal to 0.337 grams. Now, typically you will stop here, but notice that the question is saying how many milliliters of normal saline. So there's an additional step you want to do, and that is to make use of the understanding that normal saline is actually 0.9%, so 0.9 grams for 100 milliliters. It's going to be equal to 0.337 grams divided by some volume in milliliters. So that's also a slight twist they are likely to see. So you need to solve for the volume, which will be Y here, and you have 0.337 grams times 100 milliliters divided by 0.9 grams. The grams cancel out. And you end up with 37.44 milliliters. Okay, so just to emphasize, most of the difference is actually what happens in step 2. Whether it's a percentage strength or a ratio strength, you want to actually factor that into what is going on in step 2. Or in this particular step. And then on top of that, if it's not a solid that you're using, but rather you need the volume as it is in this question, then once you find the difference or the amount of sodium chloride that is needed to adjust the tonicity, you need to go ahead and use the appropriate concentrations provided to determine the volume. That's very important because sometimes students overlook it. If you stop right here, the answer will not be correct because you didn't go through to finish up the process. All right, so that's the other type that you're likely to see. Now let's look at the sixth type that you're also potentially likely to see when it comes to adjusting tonicity using the sodium chloride equivalent method. Now that is a situation where you actually have to use some other adjusting agent aside from sodium chloride. So sodium chloride is the frequently used one, but you can also use boric acid, you can use dextrose, you can use mannitol. So what happens when you have to use something other than sodium chloride? Because up to now, all the examples have been using sodium chloride. Now the process is fairly similar. There's only one additional step that you need to do. All right, so there's a fourth step more or less. Now here you have a question which says find the quantity of boric acid in grams to be used in compounding the following prescription. E value of atropine sulfate and boric acid is 0.13 and 0.52 respectively. Then you have the prescription. Atropine sulfate is 1%. The amount of boric acid that is needed is a QS. You want to calculate that. And then the volume of the preparation is 30 milliliters. So steps 1, 2, and 3 are essentially going to be the same as what we've done previously in other examples. But then there's a fourth step, which is a very straightforward step. And that's how you get from sodium chloride back to the boric acid amount. So we start off with step 1. And in step 1, we do the 0.9 grams over 100 milliliters being equal to some quantity in grams over 30 milliliters. We solve for x. X is going to be equal to 0.9 grams times 30 milliliters divided by 100 milliliters. That cancels out, and you end up with 0.27 grams. What do you do next? You move on to step 2, and in step 2, you're going to find the contribution from the atropine sulfate. So we'll do step 2 here, and in step 2, it is 1% concentration. So we do 1 gram out of 100 milliliters times the volume, which is 30 here. So times 30 milliliters. The milliliters cancel out, so you multiply the quantity in grams by its E value. The E value of atropine sulfate is given as 0.13. So you multiply that by 0.13. And that actually gives, so 30 times 0.13, that actually will give you 0.039 grams. Now we move on to step 3. And in step 3, simply find the difference. So you're going to take the value from step 1, which is 0.27 grams, and subtract from that the value from step 2, which is 0.039 grams. Now this is going to be equal to essentially 0.231 grams according to my calculator. And so at this point, everything is in sodium chloride, just for clarity. But we need to use boric acid to adjust the tonicity. So that's where the step 4 actually comes into the picture. And what you end up doing in step 4 is fairly straightforward. You take the value from step 3. In this example is 0.231 grams. And then you divide that by the E value of your tonicity adjusting agent. In this example, it is boric acid. Its E value is 0.52. So we divide this by 0.52. And that's going to be equal to 0.444 grams. So the only difference here is you go through all the 3 steps, but you don't stop at the 3rd step because everything is sodium chloride. To move on to the amount of the adjusting agent, which is different from sodium chloride, you want to divide the value in step 3 by its E value as we did here. So I hope you found this video tutorial useful. If you did, just be sure to like it and share it. And if you have any comments, just leave them in the comment section and I'll get to them as soon as I see them. Now, I don't see any questions in the chat box. At this point, I think all is clear. So my job here is done, but yours has just begun. And I'll see you in the next video.